Hello guys, welcome to today's new lecture number 2 on matrices by Maths Made Easy. In today's lecture, we will see different types of matrices and the operations we can perform on matrices. Mostly today we'll be seeing matrix addition, subtraction and multiplication by scalar. So last lecture we we got to know how to find out matrix order, what are matrix rows and what are matrix columns. So if you have not gone through that and if you have any doubt, please go back to lecture number 1. I will put that link in the description. So let's get started. So as you can see, I have listed down the different types of matrices. So let's see one by one with example. So the first one is column matrix. Okay, so a matrix is said to be a column matrix if it if there is only one column present. Oops, if there is only one column. So let's take one example. So matrix A, nothing but 2 1 5 minus 6. This matrix has 4 rows, but there is only one column. So 4 cross 1, but as there is only one column, this is known as column matrix. Okay, now let's see second example. Okay, now let's go to second type of matrix, row matrix. Similar to column matrix, but there will be only one row, and the example will be 7 9 minus 10 sin x. Okay, so if you see, there is only one row, so 1 cross, and we have 1 2 3 4 columns. So this is matrix A of order 1 cross 4, but as there is only one row, this is a row matrix. Okay, now next let's move to square matrix. Square matrix is nothing but a matrix with equal number of rows and column. So let me take matrix A. Let me take a different name so no confusion. So let's take a matrix B. I have 1 5 7 2 10 minus 2. I have 0 5 and 100. So in this, if you see, I have one row, two row, three row, three cross. How many columns I have? One, two, and three. So three. So where my m, which is number of rows, equals 3, and n, which is number of columns, are also 3. This matrix is called as a square matrix with equal number of rows and columns. Okay, so a diagonal matrix. So let's remove all this and we'll take one example for that. Okay, a diagonal matrix. A matrix to be diagonal matrix, first it should satisfy square matrix condition, that is it should be same number of rows and same number of columns. Okay, so let's take example of a square matrix. Okay, the square matrix is nothing but 1 5 9 0 2 6 11 17 0. This is a square matrix. Okay, a diagonal matrix will be all its non-diagonal elements are 0. So if you see the diagonal is this, so all this non-diagonal elements, this should be 0. Okay, so let me write one example. uh, um, so let's take matrix B 5 0 0 0 2 0 0 0 10. So if you see, only diagonal elements are present, all other are zeros. This is known as diagonal matrix. Now what is identity matrix? Okay, a matrix in which the diagonal elements are 1 and all other elements are 0. So that will be, let's take B 1 1 1 0 0 0 0 0. Okay, let me, sorry, yeah. So let me get 1 0 0 0 1 0 0 0 1. So if you see, this diagonal elements are 1 and all other elements are 0. So it's a diagonal, it's a identity matrix, and we represent it by I of 3 cross 3. 3 cross 3. A 2 cross 2 identity matrix will be um, 0, oh, sorry, 1 0 0 1, 2 cross 2, right? Okay, the last type of matrix is a null matrix. Null matrix is nothing but where all elements are 0. So we have B as 0 0 0 0, 2 cross 2 matrix, 0 0 0 0 0 0 0 0 0. It's a 3 cross 3 null matrix. Okay, so all these are the types of matrices we have. So some of the important ones are, mm, we need to know pretty much the ones we are going to use are square matrix, diagonal, and identity matrix. So need to know this to go and have better understanding of the advanced topics of matrices, correct, and need to know how to calculate order of a matrix. So I guess this lecture is all, it's already going more than the usual time. So what I can do is I can stop here. Next lecture I'll start with operation on matrices. Okay guys, so keep practicing and see you in next lecture. Have a good day. Thank you.